Hello everyone! Today, we're going to create RAG with LangChain and Ollama locally for free, and we will monitor our RAG application using Langsmith. First, we will create the virtual environment. And activate the virtual environment. After activate the virtual environment, I will create the requirements.txt file and write down all the required libraries. Now run the pip install our requirements.txt file to install the required libraries. In this video, we will use the notebook to write the code. So create the main IPN file. In this video, we are using Ollama. Ollama allows you to run open-source LLMs such as Llama and Mistral locally. Open your browser and type Ollama and click the official website link. Now download the Ollama based on your operating system. Come back to VS Code and execute Ollama pull llama 3 command for install the llama 3 locally. Let's go ahead and initialize our local model with LangChain. To do this, we are going to use the Ollama class from LangChain. Let's import the class. Next, initialize the object of this class. Now test the model. We are going to monitor or track our RAG application using Langsmith. Langsmith is a platform for building production-grade LLM applications. It allows you to closely monitor and evaluate your application. Open your browser and go to smith.langchain.com and log in using Google. Now create a new project in Langsmith and generate the API key from the settings and copy the API key. Go back to VS Code and import OS and get past. Now enter your LangChain API key. Next, import the web-based loader to load the documents from a specified web path. Now, we're loading documents using a web-based loader. This fetches documents from a specified web path. These documents will be processed and analyzed in the following step. After loading the documents, we split them into smaller chunks using a recursive character text splitter. So import recursive character text splitter. This prepares the text for further processing and analysis by breaking it into manageable pieces. Next up, we're generating embeddings from the text chunks using an Ollama embeddings model. So import Ollama embeddings. We are using Gnomic embed text model of Ollama embeddings for creating the embeddings. For this, we have the execute the Ollama pull Gnomic embed text command. Embeddings represent the semantic meaning of the text in a high-dimensional space. Then, we create a vector store from the documents and their embeddings using Chroma. So import Chroma. This allows for efficient storage and retrieval of semantic information. Now, we set up a retriever from the vector store to perform similarity-based searches. This enables the system to find relevant information based on input queries. We retrieve a prompt, likely from a pre-trained model using the LangChain hub. So import hub. This prompt serves as the starting point for generating responses. Create the function to format the document. Then, we define a processing chain using different components like retrievers, prompts, and the Ollama model. So, import runnable pass-through and str output parser. This chain managed the flow of data and processing. The output from the processing chain is parsed as a string. This prepares the final result for presentation or further processing. Finally, we invoke the defined processing chain with a specific question. The system generates a response based on the input. Now you can go to the Langsmith and monitor your RAG application.